In this lecture, we'll discuss 4-bit parallel in, parallel out, shift register, design and verification with verilog, and we'll run the code and we'll analyze the simulated output with respect to the concept we learnt in digital. So this is design code. It started with module and ended with end module. This is my module name. These are the ports. Clock reset are input ports. Parallel in also input port, but this is a vector port, 4-bit size. Clock reset are scalars, 1-bit size. Parallel out also 4-bit size, and it is a output port. In the procedural block, I wrote parallel out at the left side of the statement, so I have to write reg for this parallel out. Okay, I am writing in behavior style, so I used procedural block always at the rate of passage clock. It is with synchronous reset and working with passage clock. So either I can write 8 to 11 lines. Instead of 8 to 11, I can remove this and I can write only 13th line. If I write only 13th line, I no need this begin end. Even I keep begin end, nothing will happen. Or I can remove this 13th line, I can write these things. That's why I commented. Okay. What it indicates, I am giving parallel input. That input I have to get at parallel out. This Pi of 0 has to get at P naught of 0. This Pi of 1 has to get at P naught of 1. Okay. If I write like this also, it will work, because I mentioned these are 4-bit. So when I give data, it will take like a 4-bit data and it will assign to this as a 4-bit data. Both will work. Okay. So this is the design code. Now we'll see the test bench code. This is the run file, and this is the test bench code. So this is my file name and this is my module name. Here these are the Pi, P naught, they are vectors. Okay. You have to watch this lecture after watching serial in, serial out, serial in, parallel out, design verification lectures. Then you can understand it well. Okay. So here this is one procedural, this is another procedural block, this is another, this is another. This is for dollar finish. I used as example 100 time units. Okay. This is for reset. So here initially my clock is 0, and in this block only I wrote input generation. But in previous course I wrote this input generation separately in separate procedural block, and this forever I wrote in this block only. Either you can remove this here, you can keep here in one procedural block, and you can remove these things and you can keep in this procedural block. You can write in this way and you can write as previous lectures also. Serial in, serial out, serial in, parallel out. Both will work. Okay. So initially I am applying my input, parallel input. This is, it has no base, so it will take as a decimal. And I mentioned my parallel in is 4-bit, so it will take like a 4-bit data, 4 zeros. Okay. And after 50 time units, again I am applying another data, new data, 1000. Here I mentioned as base, binary. Okay. So here in this design, in this test bench, I am applying data 2 times. Okay. Even we can apply data 1 time only, that's also work. Okay. Right. Now we'll give this input data 4 zeros parallelly. We'll check whether we are getting that 4 zeros at the output parallelly or not. And after 50 time units, again we'll give this 1000 parallelly. Then we'll check same 1000 coming at output parallelly or not. If it is coming, our design is verified, working correctly. Okay. Now I will copy the path and I will run the code. Okay, zoom it. So here I started applying data. After applying data, this is the immediate positive clock edge. So after applying data, whenever you getting immediate positive clock edge, there you will get the parallel data. This is the parallel input data, this is the parallel output data. I am applying all zeros, I am getting all zeros. For this parallel in parallel out, I just need one clock pulse to get the output. Okay. And I am applying another new data after 50 time minutes. So this is the 50 time minutes. What I am applying 100. After applying this data, this is the coming immediate positive clock edge. So here I will get the same data. So this 1 will come here, this last 0 will come here, like that. Here also this 0 will come here, this 0 will come here. Okay. So it is working properly. Here why I am getting a red? Because I have not initialized the flip-flop outputs. Suppose if I initialize, I will get this data input output at same place. But here you can see the difference. After applying this data, in the immediate clock edge you can get. Okay. Because of this initialization, they both will come at same time. Input output, we will see that, we will check that. So here I will give equal to 0 and I will save. This is the initialization, previously not initialized. Now I will run. Zoom it. See here, both are coming at same place. So, but here you can see clearly. After applying my data, in the coming positive edge I am getting. So that's why to know clearly I used data 2 times. I applied data 2 times. Okay. So it is working properly. So design and verification of parallel in parallel out shift register completed.